All right. Hello. Good afternoon. You'll be pleased to know that I wrote just as many problems into that code base. Share the load. And it gave me plenty of fodder to talk about today. This is a GraphQL survival guide because I survived. I'd like to give a special welcome to what I'm calling ReactConf's youngest ever attendee, Eddie, who I believe is up in the loft, 5 months old. Starting them young these days. So if you can indulge me for just a moment, on the count of 3, can everyone with me please take a deep breath in and then another breath out? 1, 2, 3. Okay. Much better, thank you. Woo, all right. Here I am, I'm Petra. I'm a tech lead, architect, web developer. I'm also pretty bad at taking I'm also pretty bad at taking selfies and using these things. Here we go. I started hacking jQuery snippets together in about 2003, and nothing has been able to stop me since. Word of warning for what I'm about to talk about here. If you work on a team with GraphQL specialists, or you've got a mature API that you're integrating with, then this is not for you. That was certainly not the case for the GraphQL APIs that I've worked with. And it means that I've had to experiment a little bit, which sometimes means making mistakes. Eleanor Roosevelt says, learn from the mistakes of others because we haven't got enough time to make all the mistakes yourself. Here's a mistake. Thanks to this campsite, we know not to burn your shit at the end of a festival. So what are we talking about today? It's a joke about overly general quotes at the beginning of presentations. Good. All right, stuff to talk about. Who am I and why I'm here? Done. What's GraphQL? Why I think it's cool. And 3 things that tripped me up when I was writing applications against GraphQL, and some tips that I found worked in practice to get around them. So what's GraphQL again? It's 2 things. It's a query language, and it's a runtime for executing those queries. So if you're building a GraphQL API, your application is providing a runtime that allows other applications to query your data that exists in other places. Why do I think it's cool? And I'm not the only one that thinks it's cool, I hope. First of all, it's product-centric. GraphQL is designed from the ground up to meet the needs of interfaces and client applications. It's organized in a hierarchy. And when we have our data organized in a hierarchy, we can learn a lot about it just by looking at it. And I think React component trees are also organized into a hierarchy, but I don't know. It's also schema-driven. So if we start our API definition with a schema, that means we're providing a contract to all our applications. That's a pretty big boon. All right, so here's me, tentatively but optimistically learning to integrate a React application with GraphQL. See how that worked out. These are the 3 most critical dangers that I ran into when I was learning to integrate with GraphQL. The first being query responses that take way longer than I'd like. The second is not knowing what to call things when I'm asking for them. And the third is not knowing what to do when an error happens. So let's dig into number 1. What do you do when you deal with slow responses? Here's a diagram that you've probably seen before, but let's run through it. In the middle, that big pink logo representing a graph, clues in the name. That's our GraphQL application, our API. On the left, we've got various data sources, 1 or more data sources. They could be remote to that API, or they could be local. They might be a database, they might be a REST API, they might be a SOAP API, it might be a JSON file. doesn't matter because all of these applications over here on the right only have to integrate with one API. Saves us writing a lot of code. It saves us sharing lots of integration details between clients. And it opens up possibilities that didn't exist before. But who would have thought that combining multiple different protocols and data sources might slow things down a little when you request data? I didn't. Here's a query that I hope will look familiar if you've had the opportunity to write one of these before. So here I'm requesting a user's profile and their tracks. Each of those two nodes have some subfields or leaf nodes attached to them. If I represent that query as a tree, as I have done here on the right, this tree now represents the way that GraphQL resolvers respond to this query and in turn provide data. Now this tree is resolved in a breadth-first manner, which means that say our profile resolver is asynchronous, everything further down the tree from there needs to wait for profile to be ready. So there's a clue about where delays might be introduced. Forgot I put that in there. Amazing. So that can hide a lot of complexity, right? This tree might hide the fact that all of these nodes are actually being fetched from many and varied sources. So say, for example, I've listed here on the left a bunch of HTTP requests that represent requests to REST APIs. Don't pay too much close attention to the numbers here. I mostly made them up. They're meant to be indicative. The point I'm trying to make here is say we're querying a REST API for our user, our profile. We've got a local database. That's nice and snappy. That gives us our track listings. Once we've got that, we can go out to another REST API, fetch our artist details. Our avatar, because we're so fancy, we have a little generative art script that generates a new user avatar every time they load the page. Totally reasonable thing to want to do. That takes quite a significant amount of time. So if I add up the time that all of these rows in the tree take to execute, I'm looking at quite a serious delay. Now these delays in our data graph can be by design, that we might have asynchronous methods at the end of these requests, but also by weather conditions. And in Australia, literally by weather conditions. Whose internet gets a bit slow when it rains? Yeah. Also, networking is really unreliable. You've got latency and you've got delays that are introduced. You've got old computers running under desks. Last week, I looked at an API that was giving me a 70-second timeout. It was expecting me to wait for 70 seconds. It's out of control. It's fine. We call that legacy, but it's the stuff that we're working with. We've got to be practical. What do we do about it? Well, in the first instance, I thought, well, let's put a cache in it. An HTTP cache can take an API response, remember it, and then send that response back next time so that we don't have to do all this work to resolve the tree. But there's danger in that. An HTTP response cache is usually deciding what to return based on the URL you give it. Now, GraphQL queries are embedded in URLs over HTTP. And if I am designing an API that lets a client application request whatever it wants, that means that the query is going to change every time, so is the URL. So suddenly I have an infinitely growing list of URLs that I might like to cache. The value of that cache is going to diminish very quickly. So I wouldn't recommend that. Instead, you might have to push that caching logic further up the tube. If you put a brain in your GraphQL application, you might be able to make that data available before a client app requests it. So for example, you might attach a database to your GraphQL API application, and that could prefetch data on a schedule, or it could be push data that becomes made available via a subscription or another asynchronous or scheduled mechanism. Whatever you do, remember that just because a GraphQL API offers you a single endpoint, that doesn't mean that your application needs to fetch all of its data in a single request. It's okay, and it's sometimes preferable for applications to make small, granular requests to a GraphQL API. That's okay. Of course, there's trade-offs to be made here. We've got lots of techniques in our React applications to essentially make the user's wait time a little bit more palatable. But if we want to work more closely with our back-end developers and let them know, here's a query that's taking especially long. I don't want my user to wait. As wonderful as our loading animations are, I don't want to make them wait. How can we speed this query up? Back-end, front-end working together. The GraphQL dream is real. So you're going to have to peel back the curtain is my takeaway on this. GraphQL might give you a single interface with which to integrate your application. Doesn't mean that you're not going to have some level of understanding of where data comes from so that you can work with those back-end teams to optimize where it's going to bring the most value. If you've got an unlimited AWS budget, by all means, put K-Shawl through it. It's fine. Survival skill number 2, knowing what to call things. We like to talk about how hard naming things is. And it is hard. Lauren talked yesterday about the value of talking to different people on your team and different people in different teams and having a common language. Now that dictionary, in fancy business speak, is called a domain model. A domain model, there's a really snappy Martin Fowler quote, but I busted everything, so I can't read it. A domain model encapsulates all of your business data and behaviors. So the first thing you do if you're going to start building a GraphQL API is to write your schema, because it's schema-driven, remember? When we're writing a schema, we're not representing databases and tables. We're representing a domain. That's everything that your application or the business or the product that backs your application, everything that knows, and all of the interactions between those data points. When you're creating a domain model, you've got 4 major concerns. Firstly, what to call things. Secondly, how to make connections between things. And in database land, we've got different types of relationships. You might have heard one-to-one, many-to-one, and so on. These can be represented in a GraphQL schema, but they're also embodied there as a source of truth for you and your teams to work on. So that's a pretty valuable opportunity to establish that in one place and have the conversations about how those things work. You've got lists of things. You might ask yourself questions like, what happens when I have a list that has no items in it? Is it still a list or is it nothing? What happens if I want to paginate a list of things? And what happens when things in my list need to make a relationship to a thing on another list somewhere? But I think the hardest one here is describing in your schema how to make changes to these points in your domain model. Now remember, a domain model encapsulates your data and also behaviors on that data. Now, having experience working against REST APIs, I'm used to a world where if I want to update a user's profile, I've probably got an endpoint at user/profile. And based on REST conventions, I might choose a method. And based on that method, I might provide some body and then get back something else. Now here we have a nice illustration of the difference between a convention and a specification. GraphQL is the first time since maybe SOAP that we've had a specification versus a convention for making data operations. So of course I come along and say update profile. That sounds great. I can use that everywhere. But it turns out it's totally ambiguous. The mutation update profile doesn't tell me what fields it expects, and it doesn't tell me what I'm going to get back. And one of the things I love about the promise of GraphQL is it gives us higher confidence as client application developers. So if I'm not increasing that confidence, I'm doing it wrong. Instead, I might define a mutation called add track to profile. And without reading any further documentation, I've already got a picture in my head of what kind of data I want to provide that mutation and what I might get back. Does that mean you need an operation for every interaction in your domain model? Yes, it's a lot of work, but you got to do it. It turns out adding another mutation to a GraphQL schema is not nearly as expensive as adding another route to a REST API. So this whole idea that I had in my head of having all of the mutations that represent all of the behaviors on your data model, it's hard work, but it's worth it. All right, we're on survival skill number 3, knowing what to do when things go wrong. So this took me way too long to figure out. And the documentation is so nice, and it says it, I think, on the first paragraph, handling errors in GraphQL, but it wasn't that nice when I had to do it. In an HTTP REST API world, I usually have to rely on an HTTP response code to tell me what kind of thing went wrong if I don't get the data back that I expected to. Now that's problematic, which you might be aware of, because there's no hard and fast rules about which code means what. What I do know is that 200 means okay. Good, great. Everything is fine. Everything is not fine. I can receive a 200 response code that has some data in it and also a bunch of errors, or no errors and no data. But this is okay. It's backwards land. All right, turns out one of the jobs of integrating an application against a GraphQL API is deciding what to do when things go wrong. A little bit more work to do, probably worth it. So a successful response might look like this. Successful, I mean to say you've received a 200 response code from the server or equivalent to say there's not been a network error, there's not been any rain, everything's great. So I've got a data tree maybe coming back, but then I've also got a populated list of errors. Wow. The types of errors now you have to handle in your application if you're integrating against a GraphQL API fall into 2 broad categories. You've got these server errors, because while GraphQL by definition is transport method agnostic, meaning to say that what I've been talking about here is making requests to a GraphQL API over HTTP. But that's not the only way you can do it. We can encode a query into a URL, and that's nice. If you've ever copied a GraphQL playground URL and you get all that, that link gore, that's your entire query encoded into that URL, which is a really neat way to do it over HTTP. But you might have come across maybe an Apollo local cache pattern where you can make a GraphQL query against your application's global state. That's not going over HTTP. That's great. So in the case that your requests are going over HTTP, you're still going to want to handle those network errors that might pop up. But now that's a networking concern. That's a transport concern. Somewhere else in my application, I can handle the errors that describe what went wrong when I tried to fetch the data that I wanted. which is a much more specific and powerful thing to be able to do, because now I can say something more meaningful back to the user. I mean, what forbidden, no user should ever have to see that. No matter how you try and translate a 400 forbidden error to the user, it's probably going to be out of context of the thing you've tried to show them in the first place. So, in summary, talk to your API developers. Be aware of where the data you're requesting is coming from. Try and be adaptable in the way that you request that data. Number 2, be involved in the schema design process. Make sure that your business team, your customer support team, your design team, your QA team are all involved in the schema design process. If you have any problems getting your boss to let you talk to these people, tell him it's a safe, compliant digital transformation process, and go through the door, it's fine. Don't forget to encapsulate your user behavior in that schema. That's just as important as giving the right names to things. And finally, do the work to handle the errors in your client application, because now your client application has to handle a new class of errors. So if we've gone through all this, I've gone through all this, and I still think GraphQL is great. I still think it's worth it. It's a reasonably new technology. It's a new specification, relatively speaking, but the coverage of tools and adapters is just incredible. You can be developing an app for the web or for a native platform or for a fridge or a billboard, and there's likely to be a set of tooling that you can pick up and as a developer work with ease to integrate against a GraphQL API. Very good, very good. Writing a schema first means that you get your API documentation for free. You might have worked with a REST API in the past that gives you Swagger documentation. That doesn't come for free. Someone has to write effectively a schema, a set of instructions to say for every endpoint I can do this and that. But that's not required to make the thing work, so it's quite often deprioritized. There's no getting around it with GraphQL. Your API doco's there, and you can probably look at it in something like GraphQL Playground, see point number 1. It doesn't care about your transport method. Like I said, REST is specifically implemented over HTTP. Not the case with GraphQL. You can suddenly think about making it work in memory. You can think about making it work in new asynchronous ways. When HTTP is surpassed with something else and we're doing mind meld, or I don't know, it's not the innovation talk, clearly. But if your boss, I don't know why I'm so concerned about your bosses. I mean, GraphQL is pretty new and jazzy, right? If you haven't had the opportunity to work with it, it can be a really difficult sell to convince your teams or your bosses or your parents that putting a new thing in your stack is a good idea. But when it comes down to it, you write less code and you get more app when you're working with GraphQL. And that should be enough for any number cruncher to say, well, this is an easy win. So with that, I hope that you feel empowered to go away and give it a try. I'm PetronBot on Twitter, and these slides and also a whole set of resources that I've used to put them together are available here. Sorry, if you can't spell the name, it's on the schedule, or I think it's on Twitter as well. So thank you all very much, and I hope you enjoy the afternoon.